Basically, medical grade ventilators support several modes, but by far the most popular is what is called PEEP, which stands for positive end expiratory pressure, and SCV. And the design that you're looking at here is actually quite similar to what industry grade ventilators also have. I checked online and I found one video from one of these German ventilator websites, and I tried to, they were very kind as to share the entire schematics of how it works. And this is basically it, right? So there is a pressure tank, and then you have obviously the valves, and then you have the tubes that lead to the patient. The only difference is that typically you don't need an air compressor here, because you plug the ventilator to two sources, to oxygen on the one hand, and then normal atmospheric air pressure. So you basically feed this tank using a venturi valve to suck in oxygen mixed with air into this, and then every other thing continues from there. But we're looking at a very simplistic design. Obviously, this cannot be as complicated as an industry grade ventilator, right? So rather than, we're just going to take out oxygen out of the question and focus on having an air compressor that just compresses air into this pressure tank, and then based on that the air is released here. So this is inhalation, and then exhalation, air is let out from here. Obviously this will also go to a filter to make sure that the contaminated air doesn't infect the person that might be the one managing this machine. So this is a rough cut design of a ventilator, and we could also make this using everyday, I wouldn't say everyday parts, but parts that are relatively easy to get. So what I have here in this design is, this would typically be a 12 volt air compressor. This is just any tank that can withstand a little bit of pressure. We plug in a pressure sensor here because we're going to need it. We plug the pressure sensor here to measure this line, and then this is a valve, and then this is another valve. At the heart of this is Arduino, because once you bring in a microcontroller, then you can really achieve this or this purely from software. How would that be the case? For instance, if you want to achieve PEEP, PEEP typically says that at the end of exhalation there should be 5 cmH2O of pressure inside here. What that really means is that you tell Arduino to open this valve and shut this valve. You let the compressed air come in at a certain rate, and then you measure it. Once it gets to what's supposed to be like the peak pressure or the acceptable pressure, somewhere a bit higher, maybe about 40 cm H2, you stop that process, and then you hold on a few seconds, and then you reverse it. You close this valve, you let this valve, and then air comes out, and you measure it to make sure that once it's up to 5 cm H2, you then lock the valve to maintain that 5 cm H2 pressure in here. Now, if on the flip side you want to do ACV, which simply means allowing the patient to breathe regularly, what you're really checking is the flow rate, or the frequency of breathing, typically, which comes to like 12 breaths per minute, right? So in that case, you're almost like putting a timer here to control and sequence: open this valve, close this valve, to inhale, then close this valve, open this valve to exhale, time. So I feel that once you bring in Arduino into this equation, then you can do a lot with software, and this is readily available. I got it here for a very cheap amount, and so yeah, this is roughly the conceptual design. I'll just show you parts of it before I then actually do it. So you can see here, this is just a 12 volt cylinder valve, right? This is where I connected this to the pressure sensor, right? There are some other minor parts that are necessary. For instance, This is a MOSFET. This is a MOSFET switch. This one here, which is necessary to switch this cylinder valve. The control of that comes from output 2, and output 4 of my Arduino board, which is where you fire an instruction here to effectively switch the cylinder valve, and then once the condition has been met, you switch it off. So yeah, this part of this controls the outlet valve. So this is the inlet valve, this is the outlet valve, and then this is the pressure sensor. So this is a rough design, as you can see. What I'm missing here, I might show you another video. I tried to build a crude homemade pressure tank, and I was just having a lot of leakages here and there. So I'm like, okay, I'm gonna get back to that, right? So when I will show you this running, what I will simply do is that I've connected, I just got my car pump to pump in air directly here. So I'm just going to pump in air here, and then based on that, I'm just going to then start operating the machine. So yeah, there you go. Obviously, I've written software that runs on the Arduino. So yeah. Okay, so basically that's it. This is the Arduino controlling everything. That's the Arduino software, and I'm also monitoring the different results of the pressure sensors. Yeah. So what is missing here, as you would notice, is that there's no air compressor and there's no pressure tank. That's because I'm still waiting for a 12-volt air compressor. There is a shutdown right now in Lagos for 2 weeks, so it's impossible to get anything. But yeah, that's the rough design.